Okay, hi everybody, Mr. Taylor back again, and with this video I really want to um, put something in about real numbers, so I'm going to go just a little bit offline here with this, but I want to talk about how we estimate the principal root of a non-perfect square. We said previously that a perfect square is going to give us it's a number that let's see, say like the square root of 100. We said that's a perfect square because we know that 10 times 10 is equal to 100. So that is called a perfect square. There's many others, but just for an example. So, and we say that once we take the principal root of a number, we're looking for the positive square root, but we also know that these perfect squares like 100 also has a negative square root, and that just means we'll take the square root of 100 and change it to a negative, because a negative times a negative also gives us a positive. Well, what about when we have these numbers that are not perfect squares? Say, for instance, the number 2 or the number 3 that are not the number 5. There must be a way for us to calculate the square root for these numbers without using a TI-Nspire or TI-84 or whatever. So let's see, can we take a look quickly at the rules that I've created to help us with that. Now this is just one method, and then as I really start working problems, I'm going to give you another method as well. So again, this is one method, and I know you're looking now and first thing is on your mind, OMG, am I going to have to really do all those steps? Not really, because once you get going with this, you can figure it out really quickly. But anyway, this is something that you must have the ability to do on your 8th grade STAR assessment, and I mean, we just have to get in there. It's really not complicated. So in order to find the principal root of a number, first we find the perfect squares before the number, the perfect squares after the number. See, that's really easy to do there. You can just do that automatically. Then you subtract the distance between the two perfect squares, find the distance from the first perfect square and the square you seek, that means what you are looking for, and create a fraction, put in the distance from step 4 over the distance from step 3, turn the fraction into a decimal, which means divide the denominator into the numerator, and add the decimal to the principal root of the number before the square, not after, but before. Okay, real easy concept, but the best way for you to see it is to take a look. So here we say, let's estimate the principal square root of 98. So if we look at 98, and we can see, if I created a number line, that 98 comes between the square root of 81 and the square root of 100. I can make that better than that. And the square root of 100. So we are trying to find the actual square root of 98. So let's just put the square root of 98 here. Well, what we know, that 9 times 9 will give us 81, and 10 times 10 will give us 100. So what we've done is we've created this before and after number. So that means 81 is before, which is root 9, and 10 is after, which is root 10. Now all we have to do now is subtract the distance between 81 and 100. So in plain words, I'm going to take 100 and subtract from it 81. and I'm going to get 19. So here I take 19, and while I got you right here, let me show you what else we can do. We can take, since we know that's 9 and that's 10, we can take 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So I put 18 marks in between, and this is the second way that we can do this. So 19 units from 81 to 100. So now the distance between 81 and 98 is 17. So if I took this and subtract from here, I would get 17 over 19. Okay, well, I can also do this way, just going here. 1, 2, 3. So I know this is, well, let's go ahead and count it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So I'm going to put a dot here, big old dot there, and say that literally this is the square root of 98 right here. The square root of 98. So I can actually relate to it there. Well, if I continue with what I'm saying here, I can also say that since the fraction is 17 over 19, and I can divide, and I will get 0.894, and then I want to add that to 9.0, and I'm going to get 9.894. Now it all depends. See, very easy, very easy. It all depends on where the instructions may tell you to round it to the 100th place, may tell you to round it to the 10th place, or it may just say round to the nearest integer. It wouldn't make any sense there. I don't believe that they will be testing you over rounding to the nearest integer. Okay, so I do believe that they will definitely be testing you on rounding to the nearest 10th, but we can also look at it to the nearest 100. So anyway, depending on what they ask you, this is a very good estimate. Now, if you don't think that it's estimated correctly, go in, and we definitely need to change this from equal but to estimate. So again, we put our little two-paste symbols, and 9.89 or 9.9 depending on where they actually 9.894 depending on where they actually work. Okay, so take your TI-84 and put it in there, square root of 98, and see what you get. And remember, it's closer to 10 than it is 9. So two questions could come up. What two integers is it between? Well, 9 and 10. And is it closer to 9 or 10? And what is the exact estimate? And it would 9.89, or a good estimate. Let's take a look at the square root of 45. So again, looking at my line, I have square root of 36 first and the square root of 49. Well, of course, we know that if this is 6 and this is 7, that is going to be closer to 7 than it is 6. So we can visualize that. But then again, we can just put our little tick marks. There are 11 units, and when you subtract 36 from 49, so we can go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, maybe that's 12. But anyway, you know what I'm saying. So here, what we want to do, well, actually, I need one more because it's 13. 12, 13. Okay, so we know that if we subtract, and let's put square root of 45 on the top. If we subtract uh, 45 or 36 from 45, we're going to get 9. So coming to the left, 1, 2, 3, 4, 5, 6, 7, 8, 9. It's going to fill in right here. Okay? So it's going to fill in right here. So realistically, now all we got to do, and some people will estimate that as 6.9. I wouldn't personally do that, because I believe that if I take a better estimate is now subtracting, well, as we did, and then we're going to have 9 over 13, which gives us a decimal of 0.692. You have to do a little math, but not a whole lot of math. And then you add that back to 6, and you will get 6.692. It may seem a little odd right now, but we're going to work so many of them, because one thing I can guarantee you, when we start dealing with measurements and you're having to find these particular measurements, they will not, especially even with Pythagorean theorem, they will not be real nice little cute numbers that we can just look at and say, hey number, how you doing? Oh, I'm fine. It won't be like that. So they're going to give you challenging work, so we definitely need to know how to understand this process. Okay, estimating the square root again of the number 141. So here we know that it comes between, and let me get my line, we know that it comes between the square root of 121 and the square root of 144. Okay, so these are the ones that come between, and we are looking for this. Oh, that is so not looking good. Let me take that off of there. So we're actually looking for the square root of 141. So again, if we look at the distance between 121, we're going to get like 23 tick marks in between. I'm not going to draw those tick marks. And we know that the distance between 121 and 141 is 20. So we're looking at 20 over 23. We divide and we get something like 0.869. We add that back to 11, because here I didn't put that, but that's 11, and this should be 12. If we have the square for, or the root for 121 is 11, and the root for 144 is 12. So we'll add this back, and we will get something like 11.869, which means right here is probably where that's going to go. Okay. Really simple once you get going. The biggest challenge is being able to divide or turn your actual fraction into a decimal. That's going to be the biggest challenge. Other than that, you're going to be just fine with it. Okay, so please write this down, write this down, write this down, write this down, so when we get to class we can just easily estimate and go over these square roots. Okay, I'll see you soon.